Look up at the night sky. What do you see? Stars, galaxies, the vast, dark canvas of the cosmos. Now look at your hand. It seems solid, real, unquestionably there. But what if all of it, the stars your hand, this very moment, is not what it appears to be? What if our three-dimensional reality is just a projection? An incredibly detailed, convincing illusion painted on a distant, two-dimensional surface. This isn't science fiction, it's a profound idea at the very frontier of physics. It asks us to question the fundamental nature of everything we know. It suggests that the universe might be a grand cosmic hologram. Imagine your entire life, every memory, every person you've met, every object you've touched. It all feels so rich, so deep, so three-dimensional. We move forward, backward, left, right, up, down. Our universe seems to have volume, a genuine sense of depth. Yet some of the most brilliant minds are exploring a possibility that turns this intuition on its head. They propose that everything we experience in our familiar three-dimensional space could be an elaborate projection of information, encoded on a surface at the edge of the universe. It's a mind-bending concept that challenges our basic assumptions about reality. This isn't just a philosophical game. This idea, called the holographic principle, emerges from the deepest questions in physics. It comes from trying to unite two of our most successful theories, Einstein's general relativity quantum mechanics. When you try to make these two theories talk to each other, strange and wonderful things happen. One of the strangest is the notion that our solid-seeming universe might be nothing more than a fantastically complex light show. So, are we living inside a cosmic projection? Are we simply characters in a movie being played on the boundary of space-time? So where did this wild idea come from? It started with the strangest objects in the universe: black holes. A black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape. They are the universe's ultimate prisons. In the 1970s, the brilliant physicist Stephen Hawking made a startling discovery. He found that black holes are not completely black. They slowly leak radiation, Hawking radiation. Over immense periods, they can evaporate and disappear completely. This created a huge problem, a paradox that shook the foundations of physics. The problem has to do with information. In physics, information is a fundamental property of matter and energy. It tells you everything you need to know about a particle: its position, its velocity, its spin. A core principle of quantum mechanics. Information can never be destroyed. It can be scrambled, hidden, rearranged, but it can never be truly lost. So, what happens to the information of all the stuff that falls into a black hole? If the black hole evaporates and disappears, does all that information vanish with it? That would violate one of the most sacred laws of physics. This puzzle, the black hole information paradox, forced physicists to rethink information. Two brilliant minds, Gerard 't Hooft, Leonard Susskind, were wrestling with this problem. They looked at a peculiar property discovered by Jacob Bekenstein. Bekenstein realized a black hole's information capacity, its entropy, isn't proportional to volume. Instead, it's proportional to the area of the event horizon, as if all the information about the interior was written on its two-dimensional surface, like storing a library painted on the walls. You've probably seen a hologram before, maybe on a credit card, or a driver's license. It's that little shimmering image that looks three-dimensional. If you tilt the card, you see a slightly different angle, giving it a sense of depth. A normal photograph is flat. It only stores light from one direction. But a hologram is different. It records light from all directions, capturing full 3D information, stored on a flat, two-dimensional surface. Think of it like a window. Move your head, and you see different perspectives. The magic is that all info to recreate the 3D view is encoded on the 2D film. Cut a hologram in half. You don't get half an image. You get two smaller, slightly less detailed versions of the whole. Now, let's scale this up. Way up. To the size of the entire universe. The holographic principle suggests our universe might work in a similar way. It proposes that all the information making up our 3D reality, every star, every planet, every atom, could be described on a distant 2D boundary. It's as if the cosmos has a hard drive, the surface at the very edge of space-time. Our perception of three dimensions would be emergent, a projection from that fundamental 2D code. We think you describe a room by listing everything inside. The holographic principle says not so fast. Maybe describing the walls is enough to reconstruct the volume. A profound shift. The universe might be far less complicated and far more bizarre than we imagine. Our solid world could be a grand illusion, projected from the boundary of reality. To grasp it, rethink information. In physics, information is fundamental. The universe's source code. Every particle, every force, every interaction can be described as bits of information. Your body, your chair, the air, at their core, staggering amounts of information. To describe a glass of water completely, you'd need every molecule's position, speed, vibration, a colossal amount of information. Einstein showed matter and energy are two sides of the same coin. Holography suggests a deeper trinity: matter, energy, and information, with information most fundamental. Space's capacity is set by its boundary. Space and gravity could emerge from encoded information. Imagine the universe as a giant sphere. Everything inside can be described by a theory that lives on the surface. Our 3D world would be a projection, a hologram generated by physics on a distant 2D boundary. We are the image, but the screen is at the edge of the cosmos. This isn't a literal movie screen. The boundary may be mathematical, perhaps at infinity. The boundary physics is a quantum field theory without gravity, yet it contains all info to describe 3D space, including gravity. Like a video game's vast 3D world generated by code on a 2D chip, our universe could emerge from lower dimensional information. We think space is the stage, but space might not be fundamental. The true reality is the encoded information. 3D space could be how brains interpret that information. An object's location isn't basic, its defining information is. In 1997, Juan Maldacena made a groundbreaking discovery, giving holography a solid mathematical foundation. ADS-CFT, a precise duality between gravity in an anti-de Sitter space, bulk, and a conformal field theory, boundary, without gravity. String theory with gravity in 5D ADS is equivalent to a gravity-free QFT on the 4D boundary. Complex bulk gravity problems translate to simpler boundary problems, a Rosetta Stone for physics. ADS-CFT is a toy universe, not ours, but it's strong evidence that holography is viable. A universe with gravity can emerge from a lower dimensional theory without it. A working model of a holographic universe. Join me on a voyage to the edge of reality. Let's explore the possibility we're part of the greatest picture show in the universe, where the screen is the cosmos and the image is us. If our universe is a hologram, a projection from a two-dimensional surface, could we ever find proof? Could we see the pixels of reality? Some physicists think we might. If space is encoded, there's a limit to information. Space-time might be grainy. Zoom in far enough, and reality might look pixelated, like a screen. The GEO 600 detector in Germany, a gravitational wave observatory, once wrestled with mysterious noise. Physicist Craig Hogan proposed the noise might be holographic, spacetime's fundamental graininess. If the projection blurs at the tiniest scales, it could create a cosmic hum. The holometer at Fermilab, two powerful interferometers side by side, was built to detect that jitter. If position fuzzes due to info limits, the holometer would see it. A direct test that space is emergent. After years, neither GEO 600 nor the holometer found definitive evidence. If pixels exist, they're smaller than we can detect. But the search continues, pushing measurement to astonishing precision. Finding cosmic pixels would be historic, confirming reality is, in a sense, an illusion. The holographic principle thrills and divides. To supporters, it's a key to deep cosmic mysteries and the black hole information paradox. ADS-CFT is a powerful tool, linking gravity, quantum mechanics, thermodynamics, and information theory. Skeptics note ADS-CFT describes a universe unlike ours, and experiments have found no holographic noise. It's science in action. Bold ideas meet proof and experiment. The jury is still out. So, what if it's true? What if we really are living in a giant hologram? What would that mean for us? For our place in the cosmos? On one level, nothing changes. The sun rises, gravity holds. Your life, loves, struggles, they remain real to you. If a projection exists, it's perfect. The illusion is complete. We are part of it. We can't step outside to see the projector. But philosophically, everything changes. We'd redefine what it means to be real. Space and the third dimension might not be fundamental. They could emerge from a lower dimensional reality. All richness encoded compactly, like a cosmic zip file. Our consciousness would be part of the projection, patterns of information. It asks for wonder and humility, continuing a tradition that decentered us, from geocentrism to a vast galaxy among billions. Perhaps our 3D existence is a secondary phenomenon, a shadow on the wall of a cave. The laws governing us as reflections of laws written on the universe's edge. Asking, is reality a hologram? Is a modern heir to an ancient question. Is the world what it seems? True or not, exploring holography pushes our knowledge, our imagination, our experiments, and our mathematics. It forces us to dream bigger about the universe and our role in it, reminding us reality is often stranger and more beautiful than we imagine. Soft. Thanks for watching.